Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. So I'd like to start off our event today by thanking IBM for their sponsorship. IBM's an integral supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Alteryx, Tibco, Vertica, Databricks, Tableau, and Semantic, to name just a few. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look, because they provide some very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled Level Up Your Data Science Team, and that's going to be presented by IBM. But before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have two presenters that I'll introduce in just a minute. There'll be 10 or 15 minutes of QA following the presentation, and this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be reviewing and presenting them on your behalf during the QA portion of today's event. Well, I'm very pleased to introduce today's speakers, Alex Jones and Carlo Puglisi. Now, Alex is a product manager for data science experience at IBM. He's led and developed predictive and analytic products for over 15 years. He holds a BSc Electrical Engineering from Queen's University and an MBA from the University of Ottawa. Now, Carlo is a big data and data science evangelist for IBM Analytics, Watson, and Cloud. Carlo's a technologist with a track record of leveraging emerging technology and trends to drive business transformation. Carlo's also held previous positions as a computer programmer, manager of application development, and as a director of innovation. So Alex, Carlo, thanks for being with us today. We're looking forward to your presentation. Tired of the lone wolf data scientist myth? Figured out that data science pulls people from expertise from multiple domains? Want to learn more about how to pull data science teams together to solve tough data challenges and explore the possibilities of machine learning? Well, in today's Data Science Central webinar, Level Up Your Data Science Team, Carlo and Alex will explain data science best practices, tools, and techniques to increase collaboration and productivity. So Carlo, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you, Bill, and thank you everyone for attending the webinar today. Looking forward to spend some time with you guys. So level up our data science team. You're here with me, as Bill mentioned, Carlo Puglisi, big data and data science evangelist. I'm with Alex Jones as well. So when we start this out, today, I always like to frame why data science is becoming so popular and why it's such a hot trend right now. And it all stems back to we really live in a digital age, which is changing how we live, play, learn, and work. We share and communicate everything digitally now. I can tell you, if I try to get in touch with my kids in their other room, I could yell all I want, they won't hear me, but if I text them, they'll immediately respond. It's just the age we live in, and companies have to really adapt and change in order to compete. From things like shopping, now this past holiday season, there was more online shopping than in-store. So everything is transforming. How people communicate is transforming. The emergence of social media applications have dominated everything. So companies have to really compete, have to transform to compete. So transformation is critical. Digital businesses are disrupting at a fast pace, and but this isn't just 100% digital business. The incumbents are causing digital disruption in their industry as well. Recently, IBM sponsored a Harvard Business Review where we had participants give us feedback, and 72% of the business leaders told us that they're vulnerable to disruption within 3 years. That's a huge amount, and everybody is vulnerable to disruption, particularly in this digital space right now. Companies must make the shift to really be data-driven in order to compete. So why are we vulnerable to these shifts? There's really two main threats to most of the companies out there. First are internal threats from siloed data and gaps in our expertise and skills and unable to react quickly is really the internal threats that companies face. And then external threats are these born on digital companies that are really rewriting how customers are interacting with business, new business models, they're reinventing industries. Everybody knows about Uber. It's just kind of changed the landscape of transportation, personal transportation. So this is happening, and the amount of new companies that are out there is incredibly high. There was an estimate that 274,000 worldwide startups each day are happening. That's a lot. And the way that we got that was we looked at worldwide, there are about 300 million people trying to do startups. And about 150 million of them are going to start new businesses. So basically 2 people per business as a small company. And 1/3 will be launched, so 1/3 of those. So that's like 50 million per year. And you divide it out, it's like, it's quite a bit. So there's a lot of threats to keep aware of. So how do companies compete? Well, data is the basis for new competitive advantage. You really have to create a system of insights while dealing with a variety of tools. And a lot of vendors out there that are providing things in different ways. So companies are adapting to that. Companies have to be able to create new business models, and they have to have advanced marketing techniques for personalizing their conversation with their customers. All these things really are what's going to make you competitive. Unleashing to make the data-driven transformation, organization really has to understand and make a shift. And this is what we call our data value maturity curve. And if you look to the left, you have operations. There's, effective operations adds value, but it's not as much as new business models, which is where you really start to apply data science. And doesn't look like we're on the right slide. I'm sorry. So if from on the left, you'll see operations. The next step, you go to reporting, data warehousing. This is where you really start to modernize. Self-service analytics. This is where you become kind of a data decision company where everybody has accessibility to data in their tools. And then new business models. This is where you embed machine learning, digital applications, where the decisions are made at the edge device or where your customers are interacting. To do this, data professionals are at the forefront of that data-driven organization. We've focused in on 4 personas: the business analyst, who is really understanding the business problem; application developers, who can easily plug these new business models into your digital applications; data scientists, who are the ones that are stewards of the algorithms and the concepts that are going to be built and applied; and then data engineer, who's still critical to making that data accessible, curating it, and safe for the organization. So what I'd like to do right now is take a quick poll. Do you consider yourself principally a data scientist, business analyst, data engineer, application developer, manager, data science or analytics, or an analytics executive? We'll just take a second. If you could click on the screen and take the poll, that'd be great. Okay, good. Looks like we have a decent split. Data scientist is leading the pack, which is great. Managers, data science analytics next, and then business analysts, data engineers, application developers, and executives, which are all important. The reason I have to take this poll is to show that we're all into data science projects, but how we identify ourselves doesn't mean is important, but people that are business analysts or data engineers are still doing data science work, and just really like this poll because it helps us understand the audience base. So to that point, data science is very much a team sport. It does require multiple people wearing multiple hats. We talked about the different data professionals, from the data scientist to the data engineer, the application developer, the business analyst. They all are required to work together on a unified data set in a unified way with tools that are going to cater to the work that they're doing. As we talked about data science being a team sport, the type of work that the data scientist does as a data engineer and a business analyst and app developer are unique to that role, but there is some overlap. So if you look at transforming, cleaning, shaping data, it's heavily the data engineer, but there's some work that's being done by the data scientist and the business analyst in that regard. So the tool sets that a data scientist would use would be very different than a data engineer. And this is where we become challenging to really embrace and make data science pervasive in organizations, because there's a variety of skills in order to deliver data science because of different roles, but there's also overlap in the tools that each of them use. So it becomes a challenge, but we've really identified and worked at trying to understand this better so that we can make sure that all data professionals work together in a productive way. Really, to understand data science, I go back to, what is data science? Data science is a concept to unify statistics, data analytics, and their related methods in order to understand and analyze an actual phenomenon with data. Doesn't mean you have to have a PhD, doesn't mean you have to have all of the advanced concepts, even though a true data scientist has good mathematical background. But the definition of data science is quite vague, is general. So it's really, everybody can be involved in doing data science work. And that was the point I wanted to make, is that just because somebody doesn't identify as a data scientist doesn't mean they're not doing data science work. In order to understand the data scientist, let's look a little bit about what makes up a data scientist and their skills. There's really three main areas that make up a data scientist. One is domain expertise. A data scientist can really struggle to be productive if they don't understand the domain that they're working in. Computer science, this is related to all the tools and techniques that are applied, that data science uses to apply what they're doing. And then the math and stat side. This is the using of the data, the algorithms and the mathematical side in order to solve a problem. I put in there in the middle, the unicorn is really one person that's an expert in all three areas. That doesn't really exist. It's really hard to find that. You may find somebody that's heavily a mathematician, and they understand a particular domain, whether supply chain or financials, but they're not going to really have the computer science skills, or vice versa. Somebody can be strong in computer science and math, but not have the domain expertise. Still valuable, and this is why data science itself is a team sport. And the real data science work is happening in the overlap areas. So if you look at the overlap between domain expertise and math and stats, this is where research projects are born. If you go across computer science and domain expertise, these are engineering projects, this is software development. And then between computer science and math is machine learning. And machine learning is a very, very popular right now, and it's important to understand why. And in my opinion, machine learning is really driving the future of data science. To understand the future of data science, I typically like to go back and look at the history. So I put together this chart to just talk about where in the past has innovation occurred and what were the driving factors. And I came down to three things in the past, and what's the future is machine learning, but really it's around democratizing these things. Democratizing data science is the future, but if you go back and you look at disruption, the calculator was created a long time ago, it was manual. but it wasn't until the digital calculator and the personal devices that people could bring around that innovation occurred, where you can cheat on your tests and stuff, and they had to change all the rules in school. And then the creation of the spreadsheets in the 60s. First creation of the application didn't really cause innovation, but it wasn't until the desktop came around with Windows and Excel and Lotus that people were able to use those spreadsheets, and that really transformed how businesses handled their financials and their ledgers. So there was a lot of disruption and transformation there. And then the creation of SQL back in the 70s. And then when we had relational databases that were easily installed on desktops, object-oriented development, that trend really drove innovation in the digital space. And now we're at machine learning. And, machine learning has been around a bit, but the democratizing of machine learning is really what's going to drive the future of data science. And in my opinion, open source is really at the heart of that transformation, and understanding those technologies is going to allow companies to really democratize machine learning in their systems, as well as companies who offer software are going to democratize machine learning in their applications. So think of a future where any kind of project we have, whether it's engineering or research, you don't need to understand the mathematical side of it, but you're going to be able to apply techniques of machine learning to software development, to research. It'll be inside your systems. For example, your CRM may have automatically built in it machine learning capabilities. So there's, in my opinion, the future is really around democratizing machine learning, and this is really where artificial intelligence is born. It's based on machine learning with the added of context. So next, I'd like to really create a poll question to talk about tools, so we can understand a little bit more about what tools our audience here is using. So what tools do your data scientists use today? And this could be anybody that's doing data science work. So Python, OpenR, SAS, SPSS, Excel, or other. So if you could take a minute and please just do the poll, that'd be great. Great, Python, my favorite. So it's really helpful. Python has grown considerably in interest, and particularly around machine learning. It's a great technology. It's the one I use the most. But this is a great representation of the market out there and what's going on. So talking more about tools and application, I'm going to bring on Alex Jones. Alex, if you take it from here, appreciate it.
Yeah, awesome. Thank you, Carlo. That's actually really interesting. So the results that we're seeing on this poll are pretty much in line with the kind of things that we're generally seeing inside the industry, and kind of in line with what we see from places like Google Trends and KD Nuggets polls, etc. As you're mentioning, this is showing quite a lot of Python usage, maybe a little bit more than we overall see. But one of the other things that's interesting, we see quite a bit of SPSS and SAS. The audience may here be biased a little bit towards IBMers who are logging into our webinar here. But there is definitely within the industry still a huge amount of usage of those tools. So over the last year, though, really what we have been seeing is open source languages like R and Python being used much more commonly by data scientists. And they're experiencing much faster growth than the proprietary languages and development platforms like SAS and SPSS. And these have kind of been driven by a few factors. One of those is that there's a really widespread use academic community of open source tools. And what that's meaning is that young and graduating data scientists are coming out already knowing the open source tools and giving it a great deal of a leg up in terms of usage out there. Secondly, there's also an overall shift within the software development community at the moment. Sort of the mindset is moving much more in favor of the adoption of open source tools overall, not just in data science, but the fact that people are having much more confidence in open source tools, even for mission critical applications. And the third thing that's really out there is that the communities that are around tools like, or languages like R and Python have kind of reached a critical mass. So the number and the variety of algorithms that you're and functions and other techniques that you're seeing in the open source community really now dwarves the amount or what can be developed by any single vendor or anyone can provide in a proprietary framework. So that creates a big incentive to use that sort of big collective of open source functionality. It doesn't really show up on this Google Trends graph, but the other thing that we see out there essentially is we've generally in the past seen that our usage overall has been a little bit ahead of Python, but we're tending to see that in the last year or two that the Python usage is growing a little bit faster than R. So I think that may be a little bit to do with a sort of ease of picking that up as more and more users are coming there. So I wanted to talk a little bit about, so what tools do your data science team need to use? So as we were talking, open source languages are underlying the next generation of data science tools, but there is still a lot of usage of proprietary languages and tools like SAS and SPSS out there. So you can't really afford to forget about them, but overall, it's really coming down to tools for R, Python, and for big data. So big data sources are becoming much more mainstream, which means that any really analytic tool set needs to consider those as a core value instead of really being an afterthought as it might have been in the past. So there's a lot of sort of religious debates and arguments about R versus Python, but really the bottom line is that the toolkit for data science, any toolkit for data science needs to allow for the usage of both. So R tends to appeal more to hardcore statistical data scientists and to academia. Through repositories like CRAN, it makes a huge number of statistical tests and algorithms available to its users. But once a data scientist is proficient in using R, then they can really access all of those and use that functionality relatively straightforwardly. On the other hand, a lot of beginning data scientists and analysts or business analysts and that who are moving into open source analytics from other products often find that the syntax of R is hard to master and its learning curve is relatively steep. So Python, on the other hand, tends to appeal. It's more of a general programming language in addition to analytics. It tends to appeal to people who have familiarity with other programming languages outside of data analytics. Maybe if you think about the slide that Carlo was showing a couple of minutes ago, appeals more to people on that computer science side of the spectrum as opposed to the people that were on the real math and the mathematical and statistics side. The learning curve for adopting Python is less steep than it is for R, and all the available libraries of functionality for Python is rapidly expanding and increasing. It's also one thing that's important to think about. A lot of people, or a lot of times, it's easier to build Python applications or Python models into production applications than it is to do the same thing with R models. So a lot of data science teams, or you need to really consider in your data science team that you're going to have some members who are going to prefer to work in R, others who are going to prefer to work in Python, either because the product or the problem that's under investigation leads itself to one versus the other, or just because of the preference that they generally have in terms of tools. And data science teams and platforms really need to allow for that. It's worth noting that there's some of the tools like SPSS which are out there which allow a bit of a hybrid approach. So in SPSS you can take R and Python algorithms and functions and actually include them within a GUI-based model development environment, which allows access to some of the breadth of open source analytic libraries together with the ease of use of drag and drop UI. Enterprise data scientists really do need to be proficient in working with big data. IBM's all in on Apache Spark. Certainly probably isn't going to be a surprise to most people on this. We do a lot of talking about it and a lot of cheerleading for Spark. Because of the speed that it makes available through utilization of in-memory processing and its ease of use compared with a lot of other big data technologies. It's got a huge and growing community of users. Since it was only founded in 2009 and open sourced in 2010, Spark's rapidly become one of the most active Apache open source communities and really the most dynamic big data technology. Also, as a last thing, Carlo was talking quite a bit about the importance of machine learning, and I really want to underline that, and I'll be talking more about it later. But it's very important that data science teams have access to frameworks for machine learning like scikit-learn and SparkML, which enable them to create predictive models and to leverage those in mobile and digital beta business applications. So open source technologies are fantastic. They're great. They sort of provide the horsepower which drives next generation analytics and data science. On their own, though, they don't give enterprise data science teams everything that they really need to be successful. They're kind of like if you think of the engine of a car, which needs to be connected with all the other technologies and components in order to be really usable and effective. So what additional things are required beyond those open source tools? There's a few. First of all, you need to have a really standard shared infrastructure, which can easily be configured and accessed by all of the team members, because as we're talking data science in an enterprise really is a team sport. This may be hosted in the public cloud, or it may be available on premises behind your firewall. Second of all, there needs to be a security layer there. So the environment needs to be secure, both in terms of controlling the access to the platform itself, but also in terms of securing the data assets that are made available on that platform. It's really important that teams can share the data and the analytics that they're working with, but the sensitive data that's part of that analytics also needs to be protected and secured. So only the people who are authorized and required to use it can do so. Third area, one of the problems with open source stacks and open source analytics is really all of the moving parts that go along with them. So there's so many frameworks, libraries, and different components that it's really hard to keep kind of on top of all of those as new versions and new instances and new libraries are released. It's a lot of work to keep them current. And if some team members are using different versions or slightly different stack than other team members, that can lead to different results occurring when one member of a team is running a problem versus when another one is. And that that really creates reproducibility and credibility problems for the team results. So a common data science platform can provide a single environment in which all the components are current and compatible. Additionally, it can be hard to connect with your open source tools with the data sources that you need to work with. So an enterprise data platform can make the connections to those much easier to use in the open source tools that you're working with and facilitate working with that data. And finally, the environment that enterprise teams are working in really need to be scalable. A number of the open source tools were kind of designed and initially thought out with an individual or a desktop use in mind. An enterprise data platform really can provide they can configure those tools, and they can provide the horsepower that allows those tools to be used for enterprise scale and workloads. So I'd like to sort of pause here for a quick poll, talk a little bit about the analytics in your organization and how they're most commonly deployed into a production environment. So the question is, how are your analytic models operationalized? Do you have application developers that build them into applications? Do you have developing data scientists build them into their applications themselves? They are used in a dashboard, or do you not really make use of either final analytic applications or dashboards either because they're one-off or maybe just sort of batch usage? Anyways, if people can fill that out, that would be super. Okay, so that's interesting. So what we're seeing here, so the biggest usage that we're seeing is of dashboards. And following kind of by none of these. Interesting that at the moment there's not seeing a huge amount of handoff, or all of these are significant numbers, but the smallest number of people are actually handing those off to application developers. So I think that what that may kind of reflect, certainly with a lot of customers that we deal with, while a lot of them may aspire to kind of build their analytics into web or analytical applications, at this point, still a lot of them are being used mostly either in batch mode or just for reference as data points. So this may kind of reflect that. So the important thing, though, is that whatever the format that it takes, the value of the analytics, the value that you're getting out of your analytic models really only comes after they've been created and when they've been embedded into a business application for use by non-analysts. So the best predictive models in the world aren't really going to be much value if all they do is either sit on a desk or they get into a report, which doesn't get to the person who's actually at the pointy end of the business, actually making sales or working on a shop floor in a way that they can easily consume it. So a lot of open source data science tools are targeted around the steps that we're seeing in this diagram in the upper part. So they're really good at analyzing and refining data, experimenting with it, and then creating a model. But as enterprise data teams are becoming more mature, they really need to be a lot more focused on the parts that are towards the bottom of this diagram. So, how do you get those models into production? How can they be governed there? How can they be refined and evaluated and improved in order to have an ongoing impact that's on the business problem that they're addressing? And this kind of brings us in red to machine learning. So we've talked about it here. What is machine learning? And I guess this is partly a definition, and I also partly want to talk about how I'm talking about it in the context of this presentation. So very simply, machine learning is just the ability of computers to learn without being explicitly programmed. So machine learning means using the algorithms in order to understand patterns in the data and then to make predictions and gain insights with those. And efficient use of machine learning is a really huge area of competitive advantage in enterprise data science teams right now. I do want to say, though, it's important that to talk about when we're talking about implementing machine learning, or when I'm talking about it here, I'm not really talking about just the ability to use a particular kind of, SparkML algorithm, et cetera. What we're really talking about is the end-to-end process. So the ongoing incorporation of learning models into your environment. So this kind of includes the functionality in terms of what makes it easier to get an ML model from, your development tool into production quickly, how to provide those and determine, or how to monitor those models and figure out how well they're performing, and then how to have them easily updated when better performing models get created based on new learning that's coming in all the time. As your model's in production, you're getting new learnings, you're getting new results, and how do you incorporate all of those so that your model gets better and continues to improve in production instead of having you just sort of slowly decaying. So enabling machine learning really encompasses that whole end-to-end process that I was showing on the diagram on the last slide. So it includes incorporation of the models into business applications and facilitating the update of those for better performance. So I just wanted to show a couple of examples of machine learning models and how they can be built into applications or built into production. And I'm showing these just a couple of times because they're kind of cool examples, or a little bit because of that, but also because as we think about how models get incorporated into these environments, it sort of shows some of the other things, or I want to talk about some of the things that you need to consider when you're doing that. So in this case, this is a machine learning model which just predicts, doesn't just predict, the energy consumption of buildings. So it's been built into a dashboard, and it can be used by people like business owners or building owners who want to determine the kind of savings that they might achieve through a number of remediation activities or things that they might do to cut their energy usage. So if you look here, this is actually an example where the same kind of predictive model can be combined with things like image recognition and processing in order to be put into a chatbot where you can upload a picture of your building, and the chatbot will then talk to you about it, and it'll make some predictions based on that regarding your energy usage. So these are just a couple of examples of how ML models might be used. But as I said, I want you to sort of think about if you're looking at taking your models and incorporating them into these kind of applications, there's a few things that you want to think about. You want to be able to, one, make sure that you need to be able to use a single developed model or a single analysis in multiple different applications, which really increases the scope of usage. Two, your platform really should allow the performance of those models to be evaluated individually in each application which uses it. Three, it should be easily possible to incorporate feedback from the predictions made in these applications into improved versions of the model. And four, the model should be upgradable without impacting the applications into which it has been built. These capabilities of the platform or of platforms enable teams to move much more quickly and easily from the analysis of data into robust and productive use of those results. So as Carlo was talking about earlier, data science is becoming increasingly a team sport. So this includes not just teams that are made up of more data scientists, but also specializations and a bigger role for other data professionals like data engineers and application developers within the team. Because so much of the value of machine learning models is derived from their use within the business applications, machine learning is driving more and deeper interactions between the data scientists and business analysts and application developers. So these are the guys who are taking the models and they're building out the new business processes or reactive and intelligent applications based on them. So businesses really need to require all of these data professionals to collaborate together effectively and with as few impediments and as little between to prevent them working together as possible. So forward-looking IT organizations and data science teams really need to understand the needs of these professionals each and be prepared to satisfy all of them as they and the business problems that they're supporting. So this is a kind of just an example. It's a little bit of an idealized example, actually, but it's an example of how all of those roles or the people that are in those roles work together on a problem. So if you imagine an end-to-end organization which is built on the same platform where each professional has an experience or an interface which is tailored to their needs. So the problem can start with, in this example, what we're seeing is we have a CEO of a chain of sporting goods stores who's seeing decreasing sales. So she wants to put a business analyst onto the problem. So the business analyst uses their tools inside that framework in order to look at the problem and realize that what they really need is more data in order to do it. So they really need to combine their internal information that they have about their stores with external data, say around the demographics of the locations nearby where their stores are, and also shopping patterns in nearby shopping centers. So they talk to a data engineer. And so the data engineer works with them, again, on that data science platform, and they build out a new data source, share that with the data scientist and the business analyst. So this can be done in one place using a single platform and be immediately available, as opposed to having things sort of stuck in terms of an IT or a database that's not accessible easily to other users on the team. So the business analyst then takes and builds out new reports and dashboards and finds out new questions that are hidden in the data. They discover that foot traffic in their stores are too low. So how can they improve it? They want to figure that out. So they talk to the data scientists, work with them to try to figure out the reasons for why and how that can adjust. So the data scientist then sort of takes that information, the data source that's already been created and the information that's provided by the data analyst, experiments with it and determines that in collaboration with the business analyst, they determine that the amount of foot traffic in the stores is low and that sales can be improved through better cross-selling. And they ultimately build out a predictive model based on that passes all of their tests and can be promoted and be built into new applications. So then the information then gets handed off. So right from within that data science platform, they can publish that model and make that as something like a REST endpoint, for example, that makes that available to application developers who can then develop that into a new application which can be used in stores and kiosks in order to promote cross-sales. So then after that's in production, then the actual buyer behavior can be continually compared with predicted results on an ongoing basis, which improves the model and makes sure that its performance remains strong and excellent in production. As a result of that, I guess all of that's seen by the CEO, who calls it out to people like executives and analysts, and I guess hopefully from the CEO's perspective, he gets a nice bonus for improving his same store sales. So this is sort of an ideal scenario about how teamwork can be accomplished without any impediments between them. So what holds teams back? All of that opportunity, what is it that prevents people from realizing it? So typical data scientists and data science teams have a lot of pain points, or a number that they deal with on a daily basis. They typically struggle with things like what programming language to use. Should they be standardizing on just one, or should they be employing a bunch of them? Should they really allow anyone to use the language of their choice? What scalable implementations should they use? How do they stitch all of their components and open source components and proprietary ones together into an efficient system for getting that data science out to the organization, or the data science work out to the organization? Most data science teams really don't have enough information available about things like a data's lineage, or metadata for data sources, et cetera, or a formal way to govern the project. So that oftentimes what they do is they kind of put together a solution, but they haven't necessarily had the thought that's required about the longer term consequences of the decisions, or how the analytics can be managed and improved over time once that analysis is out there. And once that product has been developed, how do they then share the visualization? So they have the solution, they've got the model. How do they share the visualizations and dashboards with business analysts and line of business users? And how can they collaborate and share that amongst themselves? So barriers like this are what we really see as, those are the kind of things that are preventing companies really from struggling to actually get the value that they should be able to get out of their data, and also to adopt more fully improved business outcomes that come through data science. So at IBM, our mission really is to make data simple and accessible to all. So it's not really just about the data anymore. It's about how that data can be put to work and created and create more value and competitive advantage throughout your organization. So the kind of cooperative or the kind of enterprise data science problem that we're looking at is a really perfect example of how this approach, or the kind of problem that really needs this kind of an approach. So I want to take a few minutes to talk about what we've been working on at IBM as our platform for data scientists, which we've been building to address the needs of enterprise data science teams like the ones that we've been talking about so far. So to build this, we've leveraged our market experience with machine learning and predictive analytics that we've gained through products like SPSS Statistics and Modeler, collaboration and deployment services for deploying models, as well as capabilities in artificial intelligence and cognitive applications that IBM has in areas like research and the Watson platform, as well as IBM's deep experience with data management and open source initiatives like Apache Spark. So the result of all of this is IBM's Data Science Experience, or DSX, which was launched, or it was initially came into beta in September 2016 and became generally available last December, so December 2016. So the IBM Data Science Experience provides an environment that brings together everything that a data scientist really needs in one place, or that's its mission is to do that. It includes the most popular open source tools like RStudio and Jupyter Notebooks, and also includes a lot of IBM unique value adds. So functionality that builds out a community for data scientists, some social features which are integrated to make data scientists more successful, and also analytics that make it easier to deploy models into productive use. So the URL for Data Science Experience is datascience.ibm.com. If anyone on the call isn't familiar with it, I really encourage you to go over there and to check it out. So DSX is the experience. If you think about the personas that we're showing and talking about in the data science team, DSX is really the experience for the data scientist persona that we have within IBM Watson's data platform, which brings together functionality that targets all data professionals who need to collaborate on analytics. DSX has some really great capabilities for data scientists to learn together with the rest of their team on the wider community, as well as tools that are really focused around getting those and putting those skills to productive use. But in the next few minutes, what I want to talk about right here is just specifically about a couple of elements of the platform which are particularly applicable to data science teams like we've discussed today. So the first of these, we've talked about the ideal platform as one that combines open source tools with additional capabilities which help bring business values to market faster. A great example of this is how data scientists can use Jupyter Notebooks. So Jupyter Notebooks are an open source tool which are provided as part of data science experience. So notebooks on their own are a great tool for collaborative data science just because they combine code, text, and visualizations in one place, which enables one data scientist to understand and build on the work that their teammates have performed. Notebooks can also be used to explain and automate a sequence of data transformations in a way that can guarantee these steps are done repeatably such that all the collaborators on a team can understand and subsequently use. So by accessing these notebooks through DSX, though, data science teams get a number of additional benefits. As well as having access to huge libraries of like 200,000 notebooks that are available on GitHub. IBM also provides, provides a robust and curated set of libraries and components that can be used in those notebooks. So we curate that stack in order to make sure that they're all at current versions and that they work compatibly together. So by using that curated stack of components, it's much easier for data scientists to produce results that are reproducible and get to their analytics to market faster. Also, IBM provides an enterprise Spark cluster, which can be shared by the team members, and this cluster provides the horsepower that's needed to do analytics at scale. And finally, the results from the notebooks can really easily be exported from DSX and shared with teammates who are using it, or also others inside the organization, and those can be shared either with or without exposing the code that's behind the creation. Another really important feature of DSX for use by enterprise teams is the concept of projects. So this facilitates collaboration between team members. So within data science experience, users can create and manage these projects, which enable them to define groups of collaborators who are involved with their task, as well as the roles and permissions that are associated with each. The members of a project can access and collaborate all of the artifacts that they need, such as notebooks, models, and flows that they require. And they can also, within that project, access the data sources that they need for their shared business problem. All of them can access shared storage, which is available to all the project members. One other thing that you can do within the projects is you can associate a Spark instance with a project. So an enterprise can basically maximize the use of their computation resources by splitting loads as appropriate between the clusters that they own. So one really exciting area that we've been working on recently in DSX is on Watson machine learning. So this is a service which is currently in beta within our public cloud offering. And it adds a few new important capabilities. First, it gives a new automated model building capability. So the model builder allows users to create a machine learning model and all they need to do is identify the data set, a target field, and the general type of model that's required. It then utilizes a technology from IBM Research, which is called CADS, or Cognitive Assistant for Data Science. CADS can also be used through APIs in notebooks. But in the model builder, it tests the available algorithms out for the best fits and then trains the selected one in order to essentially automatically build an ML model for you. If you prefer, you can also have more control over the creation of that by controlling the transformations and the algorithms in the same wizard-like tool. So additionally, one other big important area that we're developing is the ability to deploy models into production directly from DSX. So we support 3 different types of model deployment. There's an online deployment, which essentially creates a REST endpoint, which can be used by applications that want to embed or want to score records individually or a couple of records at a time, essentially in real time. There are batch deployments, which essentially enable you to define input and output sources, which can be used for scoring large numbers of records on a scheduled basis, or streaming applications, which enable the scoring of the data, which are arriving through a queue. Finally, the machine learning also includes, or Watson machine learning also includes some model management functionality, which is exposed in DSX, which allows data scientists to track the performance of their models in production. So to summarize, data science experience provides data science teams with 3 really important areas of value. It provides a collaborative community which helps data scientists learn and share techniques. It provides a set of open source capabilities which leverage the power and flexibility of the assets developed in the communities, the open source communities themselves. And it includes IBM value adds, which makes it easier to actually use those open source tools, particularly as you're moving from experimentation to deploying the models for productive use. We believe that this is a winning combination for enterprise data science. It's kind of nice to know we're not alone. In the interest of time, I'm not going to talk too much about this, but IBM's been recognized by analysts and Developer Week magazine for data science experience and our offerings in data science and in machine learning. So we know that it's really nice to get that recognition as sort of a leading indicator, but we know that really the most important recognition that we're looking for is use by real-world data scientists like yourselves. So our goal is to develop the offering as quickly and as possibly based on feedback that we receive from you. So I really encourage anyone and all of you guys to sign up for DSX, try it out, and let us know the things that you like, dislike, or what you'd like to see added so that we can be as responsive as possible and build this out in the way that real data scientists want things to work. So this is a few links where you can find information out about data science experience and sign up for a free account. It's been a pleasure talking to you guys today about enterprise data science teams and the challenges and opportunities they face and how IBM is addressing some of these challenges through our data science platform, Data Science Experience. We have a few minutes at this point for questions and answers, so I'm just going to pass you back over to Bill to queue these up.
Well, Alex, Carlo, thanks so much for that great presentation. And we'll get started with today's Q&A session, and I want to thank the audience for their participation. We've had a lot of questions that have come in during the presentation, so we'll do our best to get through all of them in the time remaining. And during this Q&A session, I'm going to leave up this screen, which has contact information for Alex and Carlo, if you'd like to get a hold of them following today's webinar. So let's get started. One of the things I particularly appreciated about your presentation was how you are now looping in more than just data scientists and data engineering into the process, and that was evident also in the makeup of the audience from the polls that we saw. So one of the questions comes obviously from one of the folks who is not yet a data scientist, and he asks, I want to get started with machine learning. What do you recommend that I focus on and try to learn?
I could take that, Alex, if you want. So thanks, Bill. Yeah, this is a great question. We get this a lot, and the best way to approach this, particularly based on your skill sets, but within DSX, there's a lot of tutorials, and you can start to learn Python, scikit-learn, which is great machine learning, and as you begin to embrace on more bigger data sets, you would go to like a Spark ML, but it's all Python based. So I encourage people that a lot of good ways to get started is sometimes to learn the Python data science community with machine learning. It's growing rapidly, and it's an easy way to get started. It's a nice way to go. And understanding what machine learning is also important too. I don't know, Alex, if you have anything to add to that.
No, there's there's a lot of there are a number of great places that are out there where you can learn. Big Data University is another spot which has really good learning things about data science in general and languages and things in particular.
Well, thanks for that advice.
Bill,
that's good guidance. Go ahead.
I saw another question, which is quite good. Is DSX free? Yes, it's free. You can go out there and register for it. It's unlimited resources, but as you grow your data volumes and stuff, that you can increase it. I'm sorry, I didn't mean that. I don't know, Bill, how you wanted to do that. But
sure, that's okay, Carlo. That's great. But I think one of the things that caught my attention, and obviously the data science community as well as we were watching, is how you have apparently expanded the definition of Watson, because I think a lot of us still think about Watson in terms of Jeopardy and its role as a question answering machine. How has Watson evolved to become a more central part of your data science experience?
So yeah, I could take that. So unless you want to take it, Alex, go ahead and let me cut you off.
Oh, you go first. There you go.
All right. So I was going to say is that Watson from back in Jeopardy was obviously a collection of many hundreds of machine learning models with data and context in order for it to respond back to voice, respond back to text based on data it's learned and models it's built. So what we've done is we've taken aspects of Watson and we've productionized APIs that can be called and invoke that kind of solve a specific problem, particularly like if you want to convert text into tone. We have a service called Tone Analyzer, which has the intelligence and the machine learning and all the capabilities behind the scenes that Watson uses, but we've exposed it as a commercial offering that you can use in your applications. Kind of that's the approach we've had of starting to commercialize Watson. And Alex, I'll let you go ahead and add to that if you want.
Yeah, I mean, actually, probably not too much to add, just that, there's a few things. There are Watson cognitive APIs, which are available, and to some extent, Watson is a little bit of a branding that IBM is using around cognitive technologies in general that sort of go beyond, just the Jeopardy answering kind of questions that was sort of the genesis of it.
Right. Well, thanks for that clarification. A question from the audience. This fellow is clearly a data scientist and apparently comes from an organization that has a relatively small team. So the question is, I have a small team of data scientists. Do you really think that the IBM data science tools would benefit a small organization like mine?
Yeah, I mean, that's our intended audience. We really have put a lot of emphasis on bottom-up approach to our go-to-market strategy. So our tooling is designed for the, not just one or two data scientists, but the enterprise, but it does help the one or two data scientists with things like education, learning, ease of access, where you want to access your data, pulling data in. It gives you a lot of tools that simplify your life, that you don't have to install all these things yourself and make sure they're configured to manage. It's whether it's on-prem offering that we have for the more mature enterprise that has secure data behind their firewall, or if you want to do it in a fully managed hosted environment in the cloud, we kind of have an offering for you. So I'm not sure, Alex, if I missed anything there, but yes,
no,
definitely
just
very useful.
Yeah, absolutely. I mean, certainly, if it's a very small team, maybe there's less of the collaborative features that we're talking about that are important. But all of the, in fact, actually, if there's only one or two data scientists, the fact that you have that sort of curated stack of analytic tools is extremely important, and it's all available, together. You can access it in one place, and all of those values are still extremely important.
Well, Alex, Carlo, hey, thank you for some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Alex and Carlo and the IBM team so that they can follow up with you after today's webinar. I have just a few quick announcements. Please mark your calendars for June 21st. That's tomorrow. And that's our next DSC webinar, which is the Machine Learning Black Box. be presented by Data Robot. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close, and I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to IBM for their sponsorship, and our speakers today, Alex Jones and Carlo Puglisi, for their insights into today's topic. My name is Bill Vorhies. I'm very pleased to have been your host for today's event, and I look forward to seeing you all again tomorrow, June 21st. Have a great day.